Okay, problem number 2. We can break 6 down into 2 times 3. N squared can be broken down into n times n. We bring down our plus sign. 2 is a prime number. So 2 times 1, so we can just write 2. It's 2 times 1, anything times 1 is itself. N cubed can be broken down into n times n times n. Okay, what do they have in common? Well, I see a 2 in common, so I cross that out. Bring it down here. They don't have a 3 in common, so I move on. They have an n in common. They have another n in common. Okay, well, 2 times n times n, what is that? That's 2n squared. Now we ask ourselves what's left. Well, there's a 3 left over here. Bring down our plus sign. We have an n left over here. So our final answer here is 2n squared times the quantity 3 plus n, with 2n squared being our GCF. Okay, problem number 3. We don't have to write out the prime factors if we don't necessarily need them. Here I can look at this and I can say, okay, they all have a negative in common, so I know I'm going to need a negative. And I know that 16, 4, and 8 all have 4 in common. So I'm going to pull out my negative 4. Now this is a prime example of another situation in which we can use a generic rectangle. You don't have to, but you can easily use it in this situation. So I have negative 16n squared, negative 4n, negative 8. So I ask myself, negative 4 times what is negative 16n squared? Well, negative, we got that taken care of with this negative right here. 4 times 4 is 16, and I need the n squared. So double check. 4n squared times negative 4 would give me negative 16n squared. Okay, negative 4. So I just have the n here. So positive n. Negative 4 times what is negative 8? Positive 2. Very good. So this is a plus. I can write the plus. And then I can rewrite it down here as 4 times 4n squared plus n plus 2. Again, this number out here is my GCF. In this case, it's negative 4. Okay, once again, I don't have to write a generic rectangle if I don't need to. So I can look at these and I can say 28, 4, and 4. Well, they have 4 in common. So I'm going to pull a 4 out. 4 times what is 28? 4 times 7. I still have to take care of my b squared. 4 times 1 is 4. So I just have plus b here. 4 times 1 is 4. So plus 1. Double check it. 4 times 7 is 28. You get the b squared. 4 times b is 4b. It's positive. 4 times 1 is 4. Very good. So this is our final answer. I just did it without the rectangle. That's exactly right. You don't have to use a generic rectangle on these types of problems if you don't need them. Now, factoring, most of the factoring problems, we will need a generic rectangle. So on this one, we're going to have our generic rectangle. And our diamond. Okay, so we put our x squared in the bottom left. We put our 5 in the top right. 5x squared is what they multiply to, because we know to multiply these two to get this top number up here. Add to this one, so they add to 6x. Well, what multiplies to 5x squared and adds to 6x? 5x and 1x. So we can just write x and 5x. It's multiplication and addition. So it doesn't matter that I put the x over here and the 5x over there. I could have put it the other way. Just like over here, it doesn't matter which boxes I fill in with x and 5x. I just have to put one in one and one in the other. Now I ask myself, what do these two numbers have in common? Well, they both have a 5 in common. These two both have an x in common. These two both have an x in common. These two, well, there's no x in common. There's no 5 in common. So they have 1 in common. Because 1 times anything is that number. 1 times anything is that number. Anything times 1 is itself. Okay, so that means we can write our product as x plus 1 times x plus 5. Now, obviously, you could have written it as x plus 5 times x plus 1. Again, that's multiplication. Order doesn't matter. We can go up here to remind ourselves. This is our sum. We're going to put our product over here. We're going to set them equal. So, x plus 1 times x plus 5. They are equal. Two different ways to represent the same thing. They are equal. Okay, let's do another one. So we have a generic rectangle. Okay, so 42 times b squared is going to give me 42b squared. They add to 13b. Okay, what multiplies to 42b squared and adds to 13b? Well, let's see. 1 times 42 isn't going to work. 2 times 21 is not going to work. 3, does 3 go into 42? Yes, 3 goes into 42. But what is that? 3 times 14, that's not going to work. 4 doesn't go into it. 5 doesn't go into it. 6 works. Let's see. 6 times 7 is 42. 6 plus 7 is 13. Very good. So we're going to have 6b and 7b. Okay, so these two have 6 in common. These two have b in common. Let's make our 6 very clearly a 6 so we don't get our b's and our 6's. So these two have b in common. What do these two have in common? Well, no b's. They do have a 7. You always want to go back and check. B times b is b squared. B times 6 is 6b. 6 times 7 is 42. B times 7 is 7b. Okay, so we're happy there. Our product is b plus 6 times b plus 7. B plus 6 times b plus 7. That's our product. And this is our sum.